Okay. Today, today we shall be talking about development of arch and GARCH model. So that is our target today. Development of arch and GARCH model. And today we shall be using GARCH 1 model using EVIEWS. Okay. So today we shall develop a GARCH model as below. And here GARCH 1 means this 1 and 1 means there is a one arch term and there is another one GARCH term. So one arch and one GARCH. So that is called GARCH 1 model, and we shall develop it today. Okay, so this GARCH 1 model has two parts. One part is mean equation, that is part number 1, and the second part is variance equation. So we have two parts. One is mean equation, you can see from here, that is 1.1, and second part of the GARCH 1 model is variance equation, which is this one, equation number 1.2. So these two equations we shall solve today. Okay, so first we talk about equation number 1.1. Here you can see BBR is the dependent variable, C1 is the constant, C2 is the coefficient, BSR is a independent variable, and E is the residual. That is equation number 1.1. And here BBR means Bangladesh bond return, that is BBR, and C means constant, and what is BSR? Bangladesh stock return, and E is the residual. And here done, we have taken daily data of 35 days, not 35 days, 350 days daily data we have taken of all the variables. And what we have done, we have run these models. We have run model 1.1. After running, we have got the residual. After estimating mean model 1.1, equation 1.1, we have got the residual. And what we have done, we have plotted the residual from equation 1.1 here. So this one actually is the residual from model 1.1. You can see this is residual, right? And it is called figure 1.1, residual of Bangladesh bond return of 350 days. Okay, so this is residual. You can see from here. This is residual that you can see from here. So what is happening now, you just go down below. So my plan is to interpret the result, interpret the meaning of the residual that I shall be now. We see from figure 1.1. Figure 1.1 means this one, right? We see from figure 1.1 that there is a prolonged period of low volatility from 1 to 85, and so there is a prolonged period high volatility from day 90 to day 180. What does it mean? It means that you can see from here, from day 1 to day 85. Okay, this is all day. The horizontal axes are all day. Day from 1 to 350 days, right? From 1 to 350 days. And you can see day 1 to day 85 until 85 the volatility is low. Low volatility for long time. 85 days continuously. 85 days continuously there was low fluctuation for a long time. 85 days were low volatility. Again, you can see from here, from the figure 1.1, there is a high fluctuation from day 90 to day 180. You can see from here the huge fluctuation. You can see from here, right? This is the fluctuation from day 90 to day 180. That means high fluctuation for a long time, right? High fluctuation, high volatility for a long time. So, in other words, periods of high volatility are followed by periods of high volatility, and periods of low volatility tend to be followed by periods of low volatility. I'm saying again, in other words, periods of high volatility are followed by periods of high volatility, and periods of low volatility tend to be followed by periods of low volatility. What does it mean? It means that from day 1 to day 85, small volatility actually cause another small volatility. One small volatility causing another small volatility. And here you can see from day 90 to day 80, what has been happened, one big volatility has caused another big volatility. That means one big shock, one big fluctuation has caused another big fluctuation, and that has happened for a long period. So when this thing happens, then we can introduce a ARCH and GARCH model. when the residual behave like this. When the residual behave like this, then we can introduce a GARCH and GARCH model. So that I am saying here, this suggests that residual or error term is conditionally heteroscedastic, and it can be represented by GARCH and GARCH model. That means when the residual behave like this, then we can introduce a GARCH and GARCH model. Okay, now we can introduce GARCH and GARCH model because our figure 1.1 is suggesting us to introduce a GARCH and GARCH model. And here we shall introduce what? We shall introduce a GARCH 1 and 1 model. Okay, we come to the another equation of the GARCH 1 model is here, and we call it variance equation, and this one is the actually GARCH 1 model, right? This is the GARCH 1 model. You can see from here, residual derived from mean equation is used in making variance equation 1.1. That means 1.2 equation actually has derived from using the residual of equation 1.1. Okay. Now here you can see these are all independent and HT is dependent variable. What is HT? HT means, what does it mean? The variance of the residual derived from equation 1.1, that is HT. It is also known as current day's variance or volatility of Bangladesh bond return. So what is HT? The volatility of Bangladesh bond return, that is BBR, right? So that is HT. And what is BBR? Bangladesh bond return. And C3 is the constant. You can see from here, C3. And then what is C4? C4 is the coefficient of HT minus 1. HT minus 1 means 1 period lag of HT. That is called HT minus 1. Okay, here what is HT1? Previous day's residual variance or volatility of Bangladesh bond return, that is BR, and it is also known as GARCH term. That means this one actually called GARCH term, this one, right? So what is happening here? HT is the current period volatility, right? HT is the current period volatility, and ht minus 1 is the previous day volatility. Suppose this one ht is the today's volatility, suppose, and ht1 is yesterday's volatility. That means today's fluctuation depends on yesterday's fluctuation. Today's fluctuation is influenced by yesterday's fluctuation, which is ht minus 1. Okay, then I talk about e square t minus 1. What is it? And the coefficient is C5. What is e square t minus 1? It is here, you can see e square t minus 1. It means that previous period's squared residual derived from equation 1.1. It is also known as previous day's bond return information about volatility, and it is GARCH term. So in this model, here is a one GARCH term and one GARCH term. So that is why we are calling it GARCH 1, because here is one GARCH term and one GARCH term. And we can see some more variables such as IBR and another one PBR, and C6 is the coefficient of IBR and C7 is the coefficient of PBR. Okay, what is IBR? IBR is Indian bond return. It is an exogenous or predetermined variable. And what is PBR? Pakistan bond return. It is an exogenous and or predetermined variable. So what we shall do now, we shall actually estimate this GARCH model 1.2, provided we have all the data, and we have already collected data to estimate equation 1.2. And here you know that IBR and PBR are also known as variance regressor, as they can also contribute in the volatility of Bangladesh bond return in equation 1.2, right? So actually IBR and PBR also contribute in the volatility of HT. What is called HT? Volatility of Bangladesh bond return. Okay. Equation 1.2 is a GARCH 1 model, as it has one arch and one GARCH term. In other words, it refers to first order arch term and first order GARCH term. In other words, it refers to first order arch term and first order GARCH term. Higher order GARCH 2 and 3 can be appointed also, but many researchers prefers to use GARCH 1 for modeling the volatility of bond return. So that means you can use the higher order GARCH model, but we have here introduced GARCH 1 and 1 model, because GARCH 1 and 1 model provides better result, and many person also suggest to use GARCH 1 model. And here we shall estimate the mean equation 1.1 and variance equation 1.2 simultaneously under EVIEW environment. Then I talk about what is the objective of the study. This study aims to model the volatility of Bangladesh bond return and factors affecting the volatility in the returns of BBR. That means what are the factors are affecting the volatility of Bangladesh bond return. It means that what I want to say here, as I said, HT is the volatility of Bangladesh bond return. So what are the factors are affecting HT? Is it GARCH term? Is it arch term? Is it IBR? Or is it PBR? Or is it all that influence or contribute in the volatility of HT? Okay, so that is our objective of study. Okay. Okay, here we have GARCH model. Our GARCH model is 1 by 1. So that is our model. 1 by 1 means there is one arch term and one GARCH term. So that is our model. And here we have chosen daily data for us estimating GARCH 1 model, and we assume all variables are stationary. Make sure in the GARCH model all the variables should be stationary. And so what we have done, we have already estimated our model, meaning that our model 1.2, we have already estimated this GARCH model 1.2, and we have already got the result. So now we shall discuss about the result. Okay, so that is result discussion of GARCH model, which is also called variance equation 1.2, right? But this GARCH model can be estimated using few distributions. So here we have used three types of distribution to estimate GARCH 1.1 model. So they are normal Gaussian distribution, students T with fixed DF, and general error distributions, that is called GED. So we have used these three distribution in estimating GARCH 1.1 model. And what is the result we have got? Okay, so first we talk about normal Gaussian distribution. Then what result we have got? Under this distribution, arch is found significant. It means that previous days Bangladesh bond return information, that is arch, can influence today's Bangladesh bond return volatility, that is HT in equation 1.2. So meaning that arch is significant. Okay. Then the second one, under this distribution, GARCH is also found significant. It means that previous days Bangladesh bond return volatility, that is HT minus 1 in equation 1.2, is also known GARCH, influence today's Bangladesh bond return. So what we have got, arch and GARCH both are significant. It means what? It means that Bangladesh bond return volatility is influenced by its own arch and GARCH factors or own shock. That means Bangladesh bond return volatility actually influenced by its own shock or own volatility, that is arch and GARCH. And then what about Indian bond return? This variable is also found significant, meaning that Indian bond return volatility or outside shock can influence the volatility of BBR. So that is outside shock that influence the Bangladesh bond return volatility. And what about Pakistan bond return? It is not found significant, meaning that volatility in Pakistan bond return cannot transmit to BBR. That means Pakistan bond return volatility cannot influence Bangladesh bond return volatility. So what we can do, we can check it in the GARCH model. GARCH model means equation 1.2, this one, and according to the normal distribution, HT1 is significant, meaning that GARCH is significant. E square t minus 1 is also significant, meaning that ARCH is significant, meaning that ARCH and GARCH both influence the volatility of Bangladesh bond return, which is HT. So actually ARCH and GARCH actually are in the family, that means family of HT. So that is why I'm telling ARCH and GARCH are the own shock, family shock, shock within family. And we have also got IBR is significant. So, but it is outside the family, right? That means international shock, international volatility can also influence Bangladesh bond return, which is HT. But Pakistan bond return could not influence HT. So that is the outcome of GARCH 1-1 model when we choose normal distributions. Okay, so we have done it. Okay, then we go to the second distribution, next distribution, that is students T with fixed DF, and we have also estimated. And what is the outcome? Under this distribution, ARCH is also found significant. It means that previous days Bangladesh bond return information, that is ARCH, can influence today's Bangladesh bond return volatility. So the result is as before. Then under this distribution, GARCH is also found significant. It means that previous days Bangladesh bond return volatility can influence today's Bangladesh bond return volatility. So the result is as before. It means that Bangladesh bond return volatility is influenced by its own ARCH and GARCH factors or own shock. So the result is as before. And what about the Indian bond return? It is also found significant, meaning that Indian bond return volatility or outside shock can influence the volatility of BBR. Then what about Pakistan bond volatility? It is not found, meaning that volatility in Pakistan bond return cannot transmit BBR. So here we have got the same result like normal distribution. Okay, then third distribution, get with fixed parameters. What is it? Under this distribution, ARCH is significant. So here is also ARCH significant. It means that previous days Bangladesh bond return information, that is ARCH, can influence today's Bangladesh bond return volatility, that is HT equation 1.2. So the result is as before. Under this distribution, GARCH is also found significant. It means that previous days Bangladesh bond return volatility, which is HT minus 1, in equation 1.2, also known as GARCH, can influence today's Bangladesh bond return volatility. So the result is as before. It means that Bangladesh bond return volatility is influenced by its own arch and GARCH factors or own shock. So the result is as before. And what about the Indian bond return? It is found significant, meaning that Indian bond return volatility or outside shock can influence the volatility of BBR. So the result is also as before. Then what about Pakistan bond return? It is found not significant, meaning that volatility in Pakistan bond return cannot transmit to BBR. So here we have received the same result like normal distribution and student T. Okay, so we have estimated GARCH model using three distribution, and what is our result? The decision of the model or the result. So we can conclude that volatility in BBR is largely dependent on its own shock, such as arch and GARCH, and also influenced by the foreign market, such as IBR. But volatility from Pakistan bond return cannot contribute in the volatility of BBR. So what is the decision? Arch and GARCH are significant, and also Indian bond return. So all the three factors influence. Three factors means arch factor, GARCH factor, and the Indian bond return factor. All three things contribute in the volatility of HT. What is HT? Bangladesh bond return. That is called variance of residuals in other words. Okay, now we have to select the model because we have estimated three models using three distribution. So which one is the best? We have three models using three distributions. Which one is the best? To be best model, following assumptions must be fulfilled. So here we have three assumptions. First assumption, null hypothesis. There is no serial correlation. Alternative, there is serial correlations. How to check it? Using correlogram squared residual or Q-test. Then the second hypothesis, residuals are normal distributed. Alternative, are not normal. So this one can be tested using Jarka-Bera statistics. And the last one, there is no arch effect. Alternative, there is arch effect. And this can be tested using arch test. And here all null hypotheses are desirable to achieve best model status, meaning that all the null hypotheses such as there is no serial correlation, residuals are normally distributed, and there is no arch effect, So these are desirable. That means we should not reject null hypothesis. Only then the model will be best model. Okay. Now we have already tested all the assumptions. That means 3 assumptions here. And what is the result? Evaluation of models under 3 distributions. Okay, first I check under normal Gaussian distribution. What is the outcome? There is no serial correlation, no arch effect in the residual. So this is a good sign. No arch effect, no serial correlation. But the problem is that residuals are not normally distributed. So this one is a bad sign, right? Because residuals are not normally distributed. Then students with t fixed parameters. What is the outcome? There is no serial correlation, no arch effect. So this one is a good sign. But the problem is that residuals are not normally distributed. So that is a bad sign as before. So similar result like normal distributions. And what about the third distributions? There is no serial correlation, no arch effect. So that is a good sign. But again, the same thing has happened. Residuals are not normally distributed. So that is a bad sign. So similar results like normal distribution and student t distributions. So what is the problem of these 3 models? The weakness of these 3 distributions is non-normality of residuals. What is it? Non-normality of residuals. That means residuals are not normally distributed. But many suggest that non-normality in the residuals may not be that serious problem, as estimators are still consistent. That means although the residuals are not normal, but estimators are still consistent. So we can accept the model. It is told by many econometrician. They are suggesting although the residuals are not normal, but estimators are efficient. So we can proceed. We can proceed to make the model. So what is the conclusion? We can take either of the 3 models as best models. That means out of 3, we can take any one as a best model. And we can also use the best model for forecasting Bangladesh bond return volatility, meaning that GARCH model, meaning that model number 1.2, which is above. Actually here all the 3 models are the best, so you can choose any one to estimate. That means I'd come here. So this is our model, GARCH model. So we can use the model to forecast the volatility of Bangladesh bond return. Okay, today we shall develop a GARCH model, that is GARCH 1 model. What is 1? 1 means arch term and GARCH term. So in this GARCH 1 model, there will be one arch term and one GARCH term. So that we shall develop today, and we have the variables here. You can see BBR, BSR, IBR, PBR. What is BBR? Bangladesh bond return. What is BSR? Bangladesh stock return. What is IBR? Indian bond return. And PBR is the Pakistan bond return. And about all this thing, I have already discussed in the previous slide. Okay, what I do, I open this 4 variable, open as a group. You can see the data. So we have taken daily data of 350 days. You can see it is the data day 1, then day 2, day 3, day 5, day 9, day 20, day 50, day 70. So I'm going down. So the data is until see 350 days data is here. 350 days data is here. And what are the variables? PBR, Pakistan bond return, BBR, Bangladesh bond return, BSR, Bangladesh stock return, IBR, Indian bond return. And here our plan is to develop a GARCH 1 model, that means first order GARCH model. So a GARCH model has 2 parts. One is mean equation and then variance equation. This thing I have discussed in the previous video. I discussed about it. Okay, first I develop the mean equation, then I shall develop the variance equation. Okay, and what is our objective of this study? That what are the factors affect in the volatility of Bangladesh bond return? What are the factors affecting volatility in the Bangladesh bond return? Okay, so first I develop the mean equation, then I shall develop variance equation. Okay, how to make mean equation? I go to quick, right? Quick, then estimate equation. First I estimate the equation. BBR is the dependent variable, then constant, then BSR, right? This is my regression model, regression equation. So BBR is Bangladesh bond return and BSR is the Bangladesh stock return. So I run this regression model, and this is the outcomes, right? Dependent variable BBR, independent variable BSR, right? Okay, and from this model I can get the residual, right? I can plot the residual. So how to plot the residual of this model? There is a icon called receipt. You click on it. So it is the residual distribution from day 1 to day 350. You see, day 1 to day 350, the residuals are fluctuating, right? Okay, but you can see one thing, from day 1 to day 85, you can see until 85, the fluctuation is small, right? For a long time, for a 90 days, fluctuation is small. So that means what is happening here, small fluctuation is creating another small fluctuation for a long time, meaning that small volatility is causing another small volatility for a long time. Okay, again you can see from here, from 95 days to almost 180 days, right? From 95 to 180 days, volatilities are very big. That means volatility of the Bangladesh bond return is very big. And what is happening here? One big volatility is causing another big volatility for a long time in the Bangladesh bond return. So when the residuals are like this, then we can introduce ARCH and GARCH model. When the volatility like this, then we can introduce ARCH and GARCH model. That means small volatility for a long period, and also the big volatility for long period. Then only we can introduce ARCH and GARCH model. Okay, so we make our GARCH 1.1 model. How to make? I go to estimate here, then I click here, I go to ARCH model, right? I click here. Okay, so GARCH model has two parts. One is mean equation and one is variance equation. So first I write mean equation, that is BBR C BSR. That is our mean equation, right? That is our mean equation. And GARCH already given, and you can see ARCH one term, GARCH one term, meaning that this one is a GARCH 1.1 model. that is first order GARCH model, and variance regressor. You can see from here. So actually we have two exogenous variable. One is IBR and another one is PBR. What is IBR? Indian bond return. And what is PBR? Pakistan bond return. So our GARCH model is set, but last time I told you that the error distribution can be three types. One is normal Gaussian distribution. Second one is the GET distribution, and the third one is student T distribution. So out of three, first we start with the normal Gaussian distribution, right? First we start with this one, normal Gaussian. Then gradually we shall estimate other two distribution also. Okay. So now we can run the model, the mean equation and variance equation. And mean equation, actually it is equation number 1.1 from the previous video, and variance equation actually equation number 1.2 from the previous slide. Okay, I press OK. Okay, this is our model estimations. You can see from here. Dependent variable BBR, and first we are using normal distribution, and you can see from here the first portion is the mean equation. This one is the mean equation, that is equation number 1.1 in the previous video. And the second one is the variance equation, the result of the variance equation. So that is equation number 1.2 of the previous video. And here you can see the GARCH model. Actually this GARCH C3. What is C3? Okay, I am telling here how to get this C3. Actually this one is C1, this is C2, this is C3, this is C4, C5, C6, C7. So GARCH model or the variance equation start from C3, that is this one, right? C3 until C7. So this variance equation and this one is the same thing. Okay. Now here this one is actually what? Dependent variable is HT. What is HT? HT here means the volatility of Bangladesh bond return. Okay, actually what we have done, okay, first we estimate the mean equation, which is this one, right? From this mean equation we have taken the residual, and from this residual we have estimated the variance of that residual. So that variance of the residual actually here. and it has become dependent variable. So variance of the residual means volatility of the Bangladesh bond return. So that is the dependent variable. That means dependent variable actually is the volatility of the Bangladesh bond return. That is here. Okay. Okay, now we check whether in the variance equation which are significant. Okay, first I talk about this one, receipt. This one actually means E square t minus 1. E square t minus 1 meaning actually arch term, arch. So this arch term, you can see the p-value is 0, meaning that arch term is significant. That means then the second one is the GARCH term. Is it significant? Yes, because p-value is less than 5%. And what about IBR, exogenous variable or variance exogenous variable, IBR, Indian bond return? Is it significant? Yes, because p-value is very small, less than 5%. What about PBR, Pakistan bond return? What is the p-value? 34.15%. Is it significant? No, it is not significant because p-value is more than 5%. Okay, so we can come here. So we can say from here that receipt, which is arch term, is significant to explain the volatility of the Bangladesh bond return. Okay. Then GARCH. Is it significant? Yes, it is significant in the volatility of the Bangladesh bond return. Then IBR, Indian bond return. Yes, it is also significant in the volatility of the Bangladesh bond return, right? And finally PBR, it is not significant. So PBR cannot influence, the volatility in the PBR cannot transmit to Bangladesh bond return. Okay, and here what is happening, arch and GARCH, actually both are shock, both are internal shock of the volatility of the dependent variable, or we can call arch and GARCH as a family within family shock that is influencing BBR. But IBR, actually the volatility of IBR is a international shock that is influencing our volatility of the BBR. Okay, and the PBR cannot influence the volatility of the Bangladesh bond return. Okay, So what is our decision? Using normal distribution, arch significant, GARCH significant, IBR yes, but PBR is not. Okay, so this one we have done. Then we do the student T distribution, and we check what happens there. So I go to estimate, then everything remain unchanged except I change here. I take it as a student T fixed DF. I choose this one. Then other thing remain unchanged. Then OK. You see student T distribution has come up, right? Okay, now I check the variance equation. The arch, is it significant? Yes, because the p-value is less than 5%. GARCH, yes, significant. IBR, yes, significant. P-value is very small. PBR, no, because p-value is more than 5%. So it is not significant. So the same result, that in the volatility of PBR, arch and GARCH, which are own shock, influence the variability of Bangladesh bond return. IBR also shock the BBR, but PBR cannot influence in the volatility of BBR. So we have got exactly the same result. So now I check the third one, that is get, right? Distribution under get. How to get it? So I go to estimate as before. Then everything will remain unchanged except I choose get, right? I choose get here and I run the models. You see the get has come up and it is the outcome and it is the PBR, right? And what is our dependent variable? Dependent variable is the variance of the residual that we have derived from mean equation. Variance of the residual of BBR. What does it mean? It means that volatility of BBR. Okay, so here what is happening? Recede means arch significant. GARCH, it is also significant. IBR, it is also significant. But what about PBR? What is the p-value? 25.4%, which is more than 5%, meaning that PBR is not significant. So actually we have got the same result in all the three distributions. Now we shall check out of these three model, with three distribution, which one is the best? That we shall check gradually. Okay, so far we have developed three GARCH model using three distribution. Okay, now question is that out of three model, which one is the best? Okay. Okay. So first, suppose we develop the model having distribution is normal, right? First, we check one by one. Because we have developed three, we check one by one. Which one is the best? So first, I start with the normal Gaussian distribution. Other thing remain unchanged. You can see Arch1, GARCH1, meaning that this model is GARCH 1 model. So, and I estimate this model, and this is the outcome, right? Normal distribution, right? Okay, now the question is that when the model will be good, will be best. A model will be best, a GARCH model will be best when there is no serial correlation, residuals are normally distributed, and when there is no arch effect, arch, ARCH effect. When these three things will be present, then the model is the best. Okay, first I check with this one, with this model, when the distribution is normal. Okay, first I check whether there is serial correlation or not. How to check? I go to view, then I go to Residual Diagnostic, then I come here, squared residuals. We shall be doing squared residuals, this one, and suppose we choose 36 lakhs, we choose, okay. So here is the Q statistics, you can see, right? Q statistics 36 lakhs and corresponding p-value. Okay, and it is the correlogram of residual squared under Q statistics. What is the null hypothesis? The null hypothesis is there is no serial correlation. That is the null hypothesis. And we can reject null hypothesis when the p-value is less than 5%. Only then we can reject null hypothesis. But here, what is our p-value? You can see all p-value are more than 5%, right? You can see from here. What about this one? 83.1%. This one 42.4% p-value. What about the last one? 64.8% the p-value. So all are more than 5%, meaning that we cannot reject null hypothesis. And what is our null hypothesis? There is no serial correlation. So we cannot reject it, meaning that the GARCH model with normal distribution has no serial correlation. So that is a good sign. Okay, then we check whether this GARCH model has arch effect or not. Okay, how to check arch effect? I go to view, I go to Residual Diagnostic and I choose the arch, right? I choose it and it is the arch, right, already given, and I choose OK. Okay, it is the arch test, right? Arch test, test of heteroscedasticity, observed R square and corresponding p-value. How much is the p-value? 83.24%, meaning that more than 5%. What is the guideline? The guideline is that if the p-value is more than 5%, we cannot reject null hypothesis. And what is our null hypothesis? The null hypothesis is there is no arch effect. So here we cannot reject null hypothesis, meaning that we accept null hypothesis. And what is our null hypothesis? There is no arch effect. So this model, this GARCH 1-1 model with normal distribution has no arch effect. So that one is a good sign. That means the residual do not have any arch effect. So that is a good sign. Okay, the third assumption is residual must be normally distributed. That is desirable. So I check, I go to view, I go to Residual Diagnostic, then histogram normality test, right? I choose here. Okay. So here we shall be checking the Jarka-Bera statistics and corresponding p-value. What is the p-value? Less than 5%, right? So we can reject null hypothesis. Okay, here what are the hypotheses? What is the null hypothesis? Residuals are normally distributed. And what is alternative hypothesis? Residuals are not normal. And what is the desirable? The desirable is that residual should be normal. That is the desirable to become a good best model. Okay, here we can reject null hypothesis because the p-value is less than 5%. So we can reject null hypothesis, meaning that we accept alternative hypothesis. And what is our alternative hypothesis? Residual are not normal. So from this point of view, this model is not good because residuals are not normal. So what is the decision of this GARCH 1-1 normal distribution model? The decision of this model is there is no serial correlation, there is no arch effect, but so those are good sign, but there is one bad sign is residuals are not normally distributed. Okay, so this is the result for this model. Now we check the second type of error distribution, which is student t distribution, and we see about that model. Okay, I go to estimate, then this one I already checked. Now I check the student T fixed degree of freedom, this error distribution I check now, right? Okay, and other thing remain unchanged, other thing all are remain unchanged. Then I press OK. So this is the outcome, student to distributions, and I check whether all the assumptions are fulfilled or not. Okay, first I check whether this model has serial correlation or not. I go to view, I go to residual diagnostic as before. I'm following the same thing that I did before. I choose this one, correlogram, and 36 lakhs, right? As before the Q statistics here, right? You can see Q statistics and corresponding p value, right? And you can see the p value all are more than 5%, meaning that we cannot reject null hypothesis. What is our null? There is no serial correlations. So this one is a good sign for this model. Okay, then I check whether this model has a arch effect or not. Arch effect, as before, I go to view, residual diagnostic, then arch effect, and arch, right? It is already given. Okay, this is the arch test, observed R square, right, and corresponding p value. How much is the p value? 80.41%, meaning that more than 5%. What is the guideline? The guideline is that if the p value is more than 5%, we cannot reject null hypothesis. Rather, we accept null hypothesis. And here, what is our null hypothesis? There is no arch effect, which we cannot reject, meaning that we accept, meaning that in this model with student T distribution is not affecting by arch. So this one is a good sign for this model. Okay, we check the third one. What is the third one? Whether the residual is normally distributed or not. As before, I go to residual diagnostic and I check the histogram, and you can see the Jarkabera statistics and corresponding p value, right? The p value is less than 5%, meaning that we can reject null hypothesis, accept alternative. And what is our alternative? Residual is not normal. So it is the bad sign, because we have rejected the null hypothesis because the p value is less than 5%, and as a result we have accepted the alternative. What is alternative? Residual is not normal. So that is the bad sign. Okay, what is the decision of this model with student T distribution? In this model, yes, there is no serial correlation, there is no arch effect, but the residual is not normally distributed. So that is the bad sign. So this model, student T model and normal distribution model, is the same decision. What about our third model? having get. So we go to estimate. Okay, this one we have done right now. The third one is the get with the fixed parameter. We check this one. Okay, we run this model. Sorry, I've done mistake. I do again. Get with fixed parameters, right? So this is my model with get, right? And we check other thing remain unchanged. I click OK. You see get general error distribution, get, right? Okay, first I check whether this model has serial correlation or not. I go to view as before, residual diagnostic, then correlogram, squared residuals, right? I click here, and 36 as before. Okay. Okay, here the Q statistics and corresponding p-value. You see all p-values of 36 lakhs are more than 5%, meaning that we cannot reject null hypothesis. And what is our null hypothesis? Residuals have no serial correlation. So that is a good sign. Then we check the second one. There is an arch effect. So as before, I come here, arch test. Okay, arch test, observed R square and corresponding p-value 74.74%, which is more than 5%, meaning that we cannot reject null hypothesis. We accept null hypothesis. And what is our null hypothesis? There is no arch effect. So this one is a good sign. We check the third one, residual diagnostic, and we check the test of normality, and this is the Jarka-Bera, and corresponding probability is less than 5%, meaning that we can reject null hypothesis and accept alternative. What is alternative? Residuals are not normal. So that is not good sign. So what is the decision of this model? The decision of this model, there is no serial correlation, there is no arch effect, but the residuals are not normal. So there is no serial correlation, that is good sign. There is no arch effect, that is good sign. But when the residuals are not normal, that is a bad sign. Okay, what is the decision of the three model? Actually, three models have come to the same decision, that they do not have any serial correlation, they do not have any arch effect, but their residuals are not normal. So that is only bad sign. Other two are good. No serial correlation, no arch effect, that is good. But the problem is that residuals are not normal. That is bad sign. But the thing is that although the residuals are not normal, but still we can accept the model. Why? Because although residuals are not normal, but the estimators are still consistent. Estimators are still consistent, and many econometricians said that although the residuals are not normal, but still we can use the model for forecasting. still we can accept this GARCH model for for prediction or so on, right? And so we can also use the model and so on.